Okay, hello everyone. Welcome to Extra Touch Academy, where you learn, grow, and become. So we are going to be discussing about theory of logarithm, and we are going to be looking through the laws of logarithm here. So we'll start with the first one. We have what is called the multiplication law. Log bracket m times n in base b is equal to log m in base b plus log n in base b. So when they are multiplying and it means that we are going to split them out by putting your addition symbol, and they must have the same base. You can see that the base here, b, is affecting both m and n. That is why we have log m in base b plus log n in base b. So we have some examples to illustrate this first law. We have log 30 in base 6 is equivalent to, this 30 is equivalent to 6 times 5 in base 6, which is equal to, the first number here is 6. So we have log 6 in base 6 plus log 5 in base 6, because when you are multiplying, you have to add. Then we also have the second example. We have log 72 in base 2. 72 is equivalent to 9 times 8 in base 2, which is equal to log 9 in base 2 plus log 8 in base 2. Then this can also go the other way around. What do I mean? If you are coming from here, you can see that they have the same base. They are adding. So it means that we have to multiply. You pick one of the base, m times n is still mn. The same thing is happening here. We have log 9 in base 3 plus log 27 in base 3. Since they have the same base, I'll pick one of the base, one of the logarithm, which is this log 3. Then we have 9 times 27, which is equal to log 243 in base 3. Then the second law is division. When you are dividing, you are subtracting. You can see that this is over. This over means division. That is m divided by n in base b is equal to log m in base b minus log n in base b. Be careful here. You can see that m came first, not n. That's why m was here. So we have some examples to illustrate this application. We have log 100 over 3 in base 10 is equivalent to log 100 in base 10 minus log 3 in base 10. Then we have the next one. We have the next one, which is log 81 in base 3 minus log 9 in base 3. This is minus. Just like I said here, when you are going back, they are subtracting. Once they have the same base, this divided by this, and that is what is happening here. So we have 81 divided by 9, or in base 3, because they have the same base, which is 3. Then we have the power law. We have log n raised to the power of k. This k represents an index or a power or exponent in base b. So you have to take it, once the power is here, you take it to this place. So we have k log n in base b. So we have two sections we are going to be treating under this power law. We have log b in base b is equal to, once you can see that once there is no power here, the power here is 1. So that is why there is 1 here. You bring it in front. This is log b in base b is equal to 1. So the conclusion is that any logarithm to its base is 1. For example, log 10 in base 10 is 1. Any number to its base. So you can see that 10 is the same thing as the base. So we have log 2 in base 2 is 1. Log 3 in base 3 is 1. Log a in base a is 1. Log x in base x is 1. Then the second conclusion we are trying to make from this power law is that when you have only 1 here, so be careful about that. So this is base. We have the base as b, which is like b raised to the power of 0. Anything raised to the power of 0 is 1. That is why this was introduced. So when this 0 comes in front here, we have log b in base b. Any logarithm to its base. So 0 times 1 is 0. So the conclusion is that logarithm of 1 to any base is 0. For example, log 1 in base 10, 0. log 1 in base 5, 0. Log 1 in base x, 0. Log 1 in base y, 0. Then the fourth one is when you are trying to change the base. This is very important to note because in the next video, we are going to solve a question that will lead you to know how to apply this law here. So we have log c in base b. Once you want to alter their position, you introduce 1. 1 over, this base will come up here, while this c will come down. So we have an example. We have log 5 in base 3 is equal to 1 over, you can see the base here was 3, but it's now up. Then the number here, 5, will become the base. Then if you don't want to go through this, there's another thing you can do. You can try to introduce a common base in two of them. So we have log c, let's use base a over log b base a. It's still the same thing. What do you notice? You just introduce a base and just splitted it out. That is what is happening. But where we are concerned about is this. So take note of this. Then we are going to look at, before we end this video, we are going to look at relationship between indices and logarithm, because the laws of indices is still the same thing with the law of logarithm. So we have a question here. Let's go right to the question. Number 1. So we have number 1 here. If log 16 in base 2 is equal to 4x minus 1. So we are trying to learn the relationship between indices and logarithm. First of all, you ask yourself, you have to be concerned with the base. The base here is 2. So this is 2. The base raised to the power of anything at the right hand side. So this is 2 raised to the power of 4x minus 1 is equal to, the number here is 16. So that is the relationship between indices and logarithm. You can see we have logarithm here. So for you to change the logarithm to indices, the base raised to the power of what is at the right hand side, then equal to the number that is here. So this is now indices. So we have 2 raised to the power of 4x minus 1 is equal to, remember the base here is 2. So how many number of places can 2 go into 16, which is 2 raised to the power of 4? And in your equation involving indices, once the bases are the same on the left and right hand side, you equate the power. So we have the power here as 4x minus 1 is equal to 4. Let us solve. So we collect like terms. 4x is equal to 4. When minus 1 comes here is plus 1. 4x is equal to 5. Then divide both sides by 4. So our x is equal to 5 over 4. And that is the value of x for this number 1. Let's go to number 2 question. We have if log x in base 9 is equal to 1.5. Find x. Just like we did here, the base here, 9 raised to the power of 1.5 is equal to anything that is here, which is x. So we have 9 raised to the power of, this 1.5 is like 15 over 10 is equal to x. Let's try to divide. What can go? 5 go here is 3. 5 go here is 2. So we are left with 9 raised to the power of 3 over 2 is equal to x. This over 2, this 2 here is square root. This is like square root of 9 all raised to the power of 3. So let us simplify first. What is square root of 9, which is 3? So we have 3 raised to the power of 3 means 3 times 3 times 3, which is 27. Therefore, our x is equal to 27. And that is the answer there. So let's go to our number 3 question there. So we are just trying to know the relationship between logarithm, how to change logarithm to indices, and for you to be able to solve questions there. So going to number 3, we have solve for x in this. We have log 32 in base 8 is equal to x plus 2. X plus 2. Still using the same format, we have 8, the base is 8 raised to the power of x plus 2 is equal to, what is here is 32. So the bases are not the same, so we can't equate the power. So there is a relationship here. How many number of places? 8 in index form is 2 raised to the power of 3, bracket, because we already have x plus 2 here, is equal to 32 in index form is 2 raised to the power of 5. The bases are the same, so we equate the powers. So we have 3 brackets x plus 2 is equal to 5. Let's open the bracket. 3 times x is 3x plus 3 times 2 is 6 is equal to 5. We'll collect like terms. 3x is equal to 5 minus 6. 5 minus 6, because when plus comes here is minus. 3x is equal to 5 minus 6 is minus 1. So we'll divide both sides by 3. So our x is minus 1 over 3. And that is the answer there. So let's go to the last one before we conclude. We have evaluate log 64 in base x is equal to 3. So the base here, locate the base, s raised to the power of, what is here is 3, is equals to 64. So this is cube. So s is equals to cube root of 64. When cube goes the other side, it will change to cube root. Cube root means what number will multiply itself 3 times for it to give you 64, which is 4. So our x is equals to 4. But that is not what we are looking for. We have gotten the x. They say evaluate x log 8 in base 2 is equals to, our x is 4 here. So we have 4 log 8 in base 2 is equal to 4 log, what is 8 in index form? 2 raised to the power of 3 in base 2 is equal to 4, then times, in one of our law, the power law, when you have a power here, you bring it in front. But there's a number already here, which is 4. So this is 4 times 3 log 2 in base 2 is equal to 4 times 3 is 12. Any logarithm to its base is 1. So we have 12 times 1 is equal to 12. And that is the answer for this particular one here. So in the next video, we are going to go more into more questions on the logarithm and more difficult questions on how to apply the laws there. So see you in the next video.